Okay, levels of significance is a very important topic in hypothesis testing. So in this video, I'm going to explain level of significance alpha and uh, in in detail. So let's consider one example we discussed in the lecture. Mu large equal to less sorry mu less than equal to 50. Alternative is mu larger than 50. Okay, so the critical value approach, what we do is we find given alpha, okay, which called level of significance, which is given in practice and also in the final exam. We are going to find critical value. Okay, since here the null hypothesis is less than 50, so only large x bar will imply a conflicts. However, if you know the sigma, z will calculate x bar minus 50 divided by sigma over square m. If sigma is not known, it's x bar minus 50 s over square m, right? So if large x bar will lead to large z value or t value. So given alpha, the rejection rule will be if sigma is known, so z larger than z alpha. If sigma is unknown, so t larger than t alpha. Okay, so we will reject. So we will reject null hypothesis. Okay, null hypothesis given our starting point is null is correct. Okay, null correct. Or we can write in this way. These two are equivalent. Z larger than z alpha or t larger than t alpha given null is correct. Okay, these two are the same. Okay, this is our rejection rule. Now, how about type 1 error? So, type 1 error is, okay, type 1 error. What is type 1 error? You will reject null given what null is correct. Okay, so I want you to pay attention to these two. You can see these two events are identical. So the probability of this one will be equal to probability of this one. Okay, so what's that probability? That's also equal to probability of this one, z larger than z alpha. Okay, so I want you to pay attention to z distribution here. And this is how we find alpha, right? Given the probability is alpha on the right side, we can find this is z alpha. So we can find the probability z larger than z alpha is just exactly equal to alpha. Okay, so we have alpha. So it implies this one also equal to alpha, identical. This one also equal to alpha. Okay, now alpha is the given level of significance in every problem, so we can use them to find t alpha or z alpha. Also in the top, in our part B of hypothesis testing, we mentioned that alpha equal to probability of type 1 error, but we didn't prove, right? So here, it's just explanation why probability of type 1 error is correct, okay? Is equal to alpha, okay? It's equal to alpha. Now, let's make a concurrence. Alpha. The first thing you need to know about alpha is alpha is a given. Okay? Externally. And does not depend on data or evidence. No matter what data you have, alpha is given externally, does not depend. Okay? So is z alpha and t alpha. Right? So alpha is large. Whenever it's larger, it implies that it's more easily to reject. Okay, to reject. Right? The third one, which is our target of this video, alpha is called level of significance. Is also equal to probability of type 1 error. Okay, so this is some discussion about the level of significance for students who feel difficult in understanding during the lecture. So that's the end.